Hi students, in this video I'll be going through the 2012 O-Level Additional Mathematics paper 1 question 10. Alright, so this is a question regarding stationary points. Okay, so let's read the question. Here, a curve has the equation y equals to x cubed minus 3x squared minus 24x plus c, where c is a constant. Find the x coordinates of the two stationary points on the curve. Right, so this part of the question is not too difficult, okay, because we know that at the stationary points, the gradient of the curve will be 0, and therefore dy dx will be equals to 0. Okay, so the first thing they want to do is to find dy dx, and then we will equate it to 0. Right, so let's do dy dx. So dy over dx. Okay, so this particular equation is very easy to differentiate. So we get 3x squared minus 6x minus 24. Okay, so at the stationary points, okay, so remember to write your annotation. Okay, so remember to write all these phrases. Okay, at the stationary points, okay, dy over dx will be equals to 0. Okay, so now we're going to equate dy dx to 0. Okay, so before we factorize, we should notice that we can divide by 3, right, to simplify the equation. So x squared minus 2x minus 8 equals to 0. Okay, then we're going to factorize. Okay, so we have x over here. Okay, minus 8. So we are going to have plus 2 and minus 4, right? Plus 2 and minus 4. Okay, so we're going to have two x coordinates, so two stationary points. So either x plus 2 equals to 0, whereby we will get x equals to negative 2, or x minus 4 equals to 0, and we are going to get x equals to 4. Okay, so since they want us to just find the x coordinates, so these two will be the answer already. Okay, so there are two turning points. One is at x equals to negative 2, and the other one is at x equals to 4, right? So this part of the question, as you can see, 4-mark question, okay, but not too difficult, all right? Okay, let's take a look at part B of the question. Okay, so now they want us to find the value of this constant c, for which the minimum point of the curve, okay, so the minimum point of the curve lies on the x-axis. Okay, so they are saying that out of these two stationary points, one of them is going to be a minimum point and it's going to lie on the x-axis. So the clue given to you here is that since the curve, this minimum point lies on the x-axis, what can you say about the the y coordinate of the minimum point? Okay, so the y coordinate is going to be 0, right? Okay, of the minimum point. So this is the minimum point. So the y coordinate of the minimum point is going to be 0. In other words, if I know which x is at the minimum point, then I will know the pair of values of the pair of coordinates, okay, for the minimum point already. So after I know the pair of values, what I can do is I can sub the x and y inside this original equation over here, and then we should be able to find c. Okay, so now our aim is to determine which of the x values, okay, negative 2 or 4 is the minimum point. Okay, and how can we find do so? Okay, we can do so either in two ways, right? Either we use the first derivative test or we use the second derivative test. Okay, for this question, if you look at the equation given to us, after doing dy dx, we are just left with 3x squared minus 6x minus 24, right? Okay, so it's very easy to differentiate one more time to get the second derivative. So in this case, it will be more, it will be better if we use the second derivative test. Okay, it's easier. Okay, so let's do the second derivative test. Okay, so okay, let's write down the dy dx first. Okay, so dy dx is equals to 3x squared minus 6x minus 24. So we're going to find the 2y over dx squared, the second derivative, so we'll get 6x minus 6. Okay, so now we're going to substitute the x equals to 4 and negative 2 inside, and then see which one will give us the minimum point. Okay, so if you recall, if d2y dx squared is greater than 0, then it's a minimum point. Okay, so that's what we're going to look for. Okay, so let's try when x equals to negative 2 first. So when x equals negative 2, the 2y over dx squared is going to be 6 times negative 2 minus 6. So this is going to give us negative 18. Okay, in other words, this is not the minimum point, because when the 2y dx squared is less than 0, then we have the maximum point. So the maximum point occurs when x equals to negative 2. Okay, so let's try 4. So when x equals to 4, okay, the 2y over the x squared equals to 6 times 4 minus 6. So you have 24 minus 6, you get 18. Okay, so indeed, we have a minimum point over here. Okay, so what we can write is that since the 2y over the x squared is greater than 0, when x equals to 4, okay, the curve has, okay, let me write this properly. Okay, so the curve has a minimum point at x equals to 4. Okay, so based on this one, from here we can also find out, right, the x coordinate of the minimum point is 0, right? Correct? Sorry, the y coordinate of the minimum point is 0. So we know the coordinates of the minimum point to be 4, 0 already. All right. So what we can write is the y coordinate, the minimum point equals to 0. So in other words, minimum point is equals to 4, 0. Okay, so we're going to sub x equals to 4, y equals to 0 into the curve, and that will allow us to find the value of c, right? So the equation of the curve, if you recall, is y equals to x cubed minus 3x squared minus 24x plus c. So when x equals to 4, y will be equals to 0. Okay, so let's sub inside. So 4 cubed minus 3x squared, replace the x with 4, minus 3 times 4 squared minus 24 times 4 plus c will be equals to 0. Okay, so if you compute all these things, you will get negative 80 plus c equals to 0. So c will be equals to 80. Right, so c equals to 80. Okay, so indeed, this will be the answer for the part B of the question. Okay, so now I'm going to head over to Desmos. I've actually drawn out the graph using Desmos already, so we can take a look and see for ourselves how the curve looks like. Okay, so this is the curve. Okay, we found c to be 80, right? So I've replaced the c with 80, and then I've keyed in the graph, okay, the equation of the graph, and this is what Desmos have given to us. So you can see over here, we have the minimum point at 4, 0, and then the other point whereby the other station point whereby the x is negative 2, so the y will be 108. So that one will be a maximum point, because as you can recall from your working, the 2y dx squared is less than 0, right, when x equals to negative 2, okay, thereby giving us a maximum point. Okay, so it's good to use Desmos to help you to visualize the answer after you have gotten it, so that you have a better understanding of the topic. Okay, all right, so this will be the end of the video for this question.